In the next section of the weather unit, we will be looking at a number of severe weather events. The first of these is thunderstorms. We start with thunderstorms because many other severe weather events, like tornadoes and hurricanes, begin as thunderstorm-like systems. As you watch this video, you can pause and rewind as needed to help you fill in your note frame in OneNote, or you may prefer to watch the video first and return to OneNote afterward to fill in the frame from memory. The first stage of thunderstorm development is characterized by the formation of a cumulus cloud that rotates in a counterclockwise direction, making it a low-pressure system. You may recall from our discussion on pressure systems that high-pressure systems rotate clockwise or to the right while air moves downward through them, and low-pressure systems rotate counterclockwise or to the left as air is sucked upward inside of them. When sunlight hits the earth, the ground will quickly warm up, causing the air above the ground to warm up too. As we know, warm air will always rise due to convection, and as it does so, any moisture in the air will condense as temperatures quickly drop as you rise up through the troposphere. All of this condensation results in the formation of cumulus clouds. Cumulus clouds may also form as the result of a cold front, when warm air is forced to rise quickly upward. Either way the cloud is formed, the warm air is on the rise, resulting in a low-pressure system that rotates in a counterclockwise direction. The second stage of thunderstorm development is called the mature stage. This is the stage that you probably picture when you think about a thunderstorm. As warm air continues to rise through the low-pressure system, more air must be pulled into the system from below. This creates something called an updraft. The mature stage of a thunderstorm can be recognized from the ground by the anvil-shaped top that forms at the top of the cumulus cloud. This happens because freezing winds at the top of the troposphere blow this part of the cloud forward. Within the updraft, the air is very choppy, resulting in what is called turbulence. You may have experienced turbulence on an airplane when the ride becomes very bumpy and the pilot has you return to your seat and buckle up. This actually makes a lot of sense, as cumulus clouds and airplanes occupy a similar part of the atmosphere. As a result of this turbulence, cloud particles within the updraft collide and become larger in a process called coalescence. To help you picture what this looks like, think about how rain droplets collide and grow on the windshield of your car when you're driving in the rain. If these particles or droplets within the cloud become large and heavy enough, they begin to fall as precipitation. If turbulence inside the cloud is great enough and the cloud particles collide with enough force, electrons or negatively charged subatomic particles can be stripped from some cloud particles and deposited on others. This means that the cloud particles are no longer electrically neutral. Some become positively charged and others become negatively charged. The positive particles stay at the top of the cloud and the negative particles will settle at the bottom. Because opposite charges attract and like charges repel, the negative part of the cloud drives negative particles away from the surface of the ground, leaving it with a net positive charge. Due to the resulting charge difference between the negative bottom of the cloud and the positive surface of the ground, electricity is discharged from the cloud to the ground. This is lightning. As lightning cuts through the air warms to over 30,000 degrees Celsius, causing it to expand rapidly. As the expanding air particles crash into one another, we hear that sound as thunder. A bolt of lightning is approximately 1 kilometer away for every 3 seconds counted between seeing the lightning and hearing the thunder. The final stage of a thunderstorm is called the dissipating stage, which brings the storm to an end. As rain falls and cools the air, it creates a downdraft. The downdraft prevents more warm air, which is the source of the storm's energy, from being pulled into the cloud. Rain will only continue to fall as long as the storm has a moisture supply, making the storm system self-limiting. You should also be aware of a few additional pieces of information about thunderstorms. It has been estimated that there are more than 40,000 thunderstorms a day on planet Earth. Although a typical thunderstorm lasts only about 30 minutes, a lot of damage can be done in this time. Some of this damage occurs because of lightning, strong winds, wind shear, which is an abrupt change in wind speed or wind direction, hail, and flash floods. Flash floods occur when there is a sudden and significant amount of rainfall. When rain falls in this way, the ground may not be able to absorb such a massive amount of water quickly enough, causing the water to flood into low-lying areas. These are different from broadside floods, which are associated with melting winter snow and heavy spring rainfall. Unlike flash floods, broadside floods can usually be predicted in advance. Although broadside floods are the ones we are most familiar with here in Winnipeg, floods of both types can occur anywhere on Earth except Antarctica. The reason for this is because of Antarctica's low temperatures, making rainfall very unlikely. It would fall as snow instead. The low temperatures also make it unlikely that that snow would ever melt away. Environment Canada issues severe weather watches and warnings to let the public know about approaching storm systems, like thunderstorms, tornadoes, or blizzards. A severe weather watch is issued when there is a threat of a severe weather event developing in a specified area over a certain period of time. A severe weather warning is issued when the severe weather has actually been observed, whether visually by a human or by technology such as Doppler radar.